Hello, my name is Ulf Fredrik Unhammer. I'm a PhD candidate at the Sapiens Center for Early Sapiens Behavior at the University of Bergen. I'm going to talk to you about the joint set of fire-related experiments carried out in early 2020 with 5 colleagues from the Sapiens Center. While my colleagues designed experiments centered on material tied to their research focus, I instead wanted to implement the 3D recording I do for my PhD work into the documentation strategy of the experiments. The talk today will focus on this, and I will show you the design, development, and some preliminary results. The idea was that employing high-resolution 3D recording of our fire experiments could benefit 4 important factors. Firstly, it would give us a greater spatial control over different artifacts and elements in the experiment. Second, we would be able to achieve precise and interactive record. Thirdly, it would greatly improve the transparency of our experiments. And finally, it would make it easier to successfully replicate and expand on the experiments in the future. The strategy and methodology we would use to achieve this was already familiar through the documentation procedures we used during excavation. In short, we would use a method called digital photogrammetry for the 3D surface recording and the total station for positional recording and geographical referencing. This foreign digital data would then let us study the spatial relations in a GIS solution. During our experimental season, 5 different fires would be performed, each with a respective controlled fire. Each fire would be the responsibility of one researcher, but assisted by the team. It was therefore clear that if we standardized the framework in which the experiments were carried out, this would allow us to integrate our material in each other's fires, allowing each researcher to subject and extract his or her material to more fire scenarios. This meant that besides introducing a 3D recording strategy for the experiments, facilitating for data integration between multiple experiments called for the design of a standardized experimental space and layout. It was agreed that a box with the interior dimensions of 1 by 1 by 30 centimeters would serve as our experimental space. Within the standardized frame, we would be able to record the experiments at key stages during assembly, burning, and re-excavation. In total, we had 4 boxes made, allowing us to carry out 2 experiments at the same time. The simple and standardized design meant that transport and assembly was easy. Once assembled, the boxes were spaced out and sandbags were used to create a level surface area. The bottom 15 centimeters were filled with industrial sand and functioned as a sterile base and heat buffer. The remaining 15 centimeters were filled with dune sand. Now, in case you're wondering, the experiments consumed quite a bit of sand. In fact, one box holds roughly half a ton of sand. The number and placement of temperature probes and experimental material varied between the different fires, but we kept to 4 different levels: the surface and 5, 10, and 15 centimeters below the surface. Once each surface was prepared, it was recorded using the total station and digital photogrammetry. For the photogrammetric recording, we used a 3-stage recording strategy. First, about 20 images were taken at an oblique angle in a clockwise pattern, circling the experiment with each image covering the whole scene. Then, about 16 close-up images were taken at the top-down angle in a grid pattern. Lastly, close-up images were captured of complex features and important details. The image capture would normally take less than 5 minutes and result in about 50 images. During the course of the whole season, we recorded a total of 205 surfaces, which gave us a staggering 10,000 images. For the spatial recording, we used a total station to set up a local coordinate system. Besides recording artifact positions, we used the total station to record 8 markers attached to each experimental box. These were used to spatially reference each model. As the box remained in a fixed position during the whole experiment, these markers did not need to be re-recorded for each 3D model. The workflow of organizing and processing images into 3D models was pretty standardized for digital photogrammetry. We used Agisoft Metashade, which allows us to do on-site processing and quality assessment. The average time of processing came to between 20 and 40 minutes, with an even split between manual and automated work. It should be noted that we had access to both a powerful laptop computer and a high-end digital camera, so these times will vary depending on equipment. The high-end camera meant that we eventually ended up with a very large dataset of over 1 terabyte. As a safety measure, we therefore used 2 external hard drives for backup, and now, post-season, have an additional cloud backup. Once the fires had burned down and cooled, the process of sampling and re-excavation began. One goal was to record a full hearth profile. The sediments were quite unstable, especially the unburned dune sand. We therefore used a transparent glass or plexiglass plate to stabilize the sediments. We could then gradually excavate the hearth and document the surface at different levels. When inserting the stabilizing glass, some smearing of sediments was caused. In order to clean up the profile, we attempted to use moisture to stabilize the sediments, but the unburned dune sand turned out to be highly hydrophobic. This is an important factor to keep in mind for future experiments. Now, I would like to use the last part of my talk to show you some preliminary results that we have. To do this, I will use the second and most long-running fire experiment of the season. In this experiment, a fire was kept running for 11 days, and the cleanup of ashes through sweeping was done twice. A control fire was kept burning in parallel with no cleaning. Both fires were recorded layer by layer from the sterile sand at 15 centimeters and up to the surface. The configuration of logs in the first fire was also recorded. The consequent fire and ash pile was then recorded at several stages. Perhaps unsurprisingly, but still important, we are able to observe how the proximity between the base of the fire in the maintained hearth and material decreases after sweeping. Additionally, we can track how the ash pile of the unmaintained fire gradually grows. Looking at the excavation, we can compare the heat discoloration caused by the fires. We also have an exact position of the micromorphological samples taken from the sediments. Reaching the base of one side of the hearth, we can then study the hearth profile of each fire. Moving over to the other side of the profile, the last thing I want to show you is the experimental material. Now, naturally, the surface of the material in the maintained fire was removed by the time of excavation, as it had been dug away during sweeping. In the unmaintained fire, however, we can see that while the material remains in place, some pieces have moved around. down at 5 centimeters, we can observe a similar phenomenon for both fires. At both 5 and 10 centimeters, we can also see that some compacting of sediments have occurred, as the material pre-fire were recorded at a slightly higher position than during excavation. Finally, we can have a look at both the top-down imprint of the fire in the sterile sand and some of the active layers from the unmaintained fire. So, in conclusion, we were able to successfully create an accurate 3D recording of our experiments over time, in practice providing us with a 4D record of each experiment. This record provides a good visual and spatial understanding of the experiment parameters when reviewing and analyzing the results. It can also facilitate a higher degree of transparency. Lastly, I believe that the standardization of the workspace recording method and 4D recording I have shown goes a long way in the way of ensuring that the experiments can be successfully replicated in the future, and that the results of such experiments more easily can be compared with the data from this season. The implementation of this 3 to 4D recording has provided some useful experiences, which I would like to share with you in case you are considering using this yourself. First, the total station that we used is not strictly necessary. If the framework containing your experiments is rigid, it's possible to set up a box-specific coordinate system, like you see here in the image. Artifacts and probe locations can then be extracted directly from the 3D surfaces, given that they are visible during recording. In hindsight, I see that bringing the whole team up to a higher level of confidence with this recording methodology prior to starting out with the experiments would have been greatly beneficial, as it would have allowed for greater flexibility of roles during the experiments. The amount of data storage is greatly dependent on your camera and the number of surface recordings you will perform, but do not underestimate the amount of gigabytes that you will accumulate. Now, we wanted to use authentic sediments to better simulate the actual conditions of fires we see at the archaeological sites. But there is a great difference in how easy it is to stabilize washed industrial sand and dune sand. I believe that we could have had greater success in this and then consequently creating hearth profiles if we had had more time to let the moisture slowly seep into the materials. But I believe we're talking days. Additionally, having a different way of introducing the moisture could have worked. Lastly, there was some initial discussion as to whether the wooden boxes would catch fire during experiments, but I can confidently say that filling them up to the rim with sand and creating a flush surface works well. Rather, be aware that laminated wood and water do not play well together. Using a similar documentation strategy as that of an archaeological excavation makes it easy to compare the results of our experimental season with features observed on site. Having this stage-by-stage record of a hearth feature from the experimental season provides us with an intuitive dataset that we understand the process behind well. This in turn has the potential to let us better interpret and understand archaeological features on site and go back to the record from past excavation seasons to look at features with new eyes. I would like to give special thanks to my colleagues in the experimental crew of 2020 for their help and support, and Arno van der Westhuizen at Woodwork Design and Craft in Cape Town for his excellent work of turning my designs into the boxes we used during the experimental season. I gladly welcome any feedback and questions. Thank you.